Okay, students, we are going to do a quick, well, maybe not so quick, video demonstration of how to use Excel in stranded materials calculations. For some technical reasons, I'm only going to do the recording in Excel, so I won't have any other programs open. So everything will be done inside Excel. So I've just copied and pasted the solutions into a spreadsheet. So remember we had the test 3, there was the UDL, and we needed to work out the length, the load intensity, the delta max, and the pin support and the inflection point. So I did some calculations. Let's just make it a bit smaller. So this was the system. We had a beam fixed to a wall supported by a roller, and there was a flexural rigidity. There was a reaction moment, so the EI for the beam was given, the reaction moment was given, the angle at 1/3 along the length was given, and then we needed to find everything else. We did a free body diagram. It was a statically indeterminate system. We chose the reaction at the wall, MA, as the statical redundant, and then it became a statically determinate system. In other words, we assumed a value, and then the rest of the reactions were determined in terms of that assumed value. We did a free body diagram, we worked out the bending moment, we integrated it, we worked out the constants, and at the end of the day, we came to an equation to work out the results. So we'll do it in two parts. I'll first explain how to type in the formulas in Excel, and then I'll explain how to plot curves and work out gradients and derivatives and all of that type of thing numerically. So you read through it in your own time, and then I will give a demonstration of how we would do the calculations. So pay attention to what we have in this tab for sheet 3. These are called tabs in Excel. So we start on a blank piece of page, so to speak. We enter in a value for the flexural rigidity. In this case, it is 1.0400324 exponent 4. I click on it with the mouse. I right-click on it. I say Format Cells. And then in scientific, I then put in, let's say, 10 decimal places. I then enter in the other information, the reaction moment, which is 24.207, 265.24, and then the angle theta, which is minus 2.04404.523 exponent minus 4. I left click with the mouse button, I press shift, and then I left click again with the mouse button, then I right click with the mouse button, and then I format the cells, and I just make everything as 10 decimal places for convenience. Okay, we can always save the work every so often in Excel. So that is basically the information that was given. We did the analysis, and now we just want to work out some results. So we're going to use the formula for the length, which is minus 162/17 f theta over ma, and then I will show how to enter this in Excel. So if we want to work out a value for L, we will say in the cell it is equal to, and then we put in the information. So this would be minus 162/17, close the bracket, times numerator. I would open a bracket, I would click on the value for f, then I would multiply it by the value for theta, I would close it, and then I would divide by the denominator, which in this case is ma. Then I would press enter, and that's the answer for the length. Now we want to enter in the value for the load intensity. Q is minus 1296/17 f theta over L cubed. We go back, and we put in the formula for Q, and that would be equal to minus 1296 over 17, close the bracket, times, open the bracket for the stuff in the numerator. That would be F times the value for theta, close it, divide by things in the denominator, and that would be dividing by L cubed. So we just put the value for L, which we worked out, and then we'd say up arrow for the power 3, close bracket, enter. That's the value for Q. And if we wanted to change how it looks, we'd click with the left mouse button, right click on it, format cells, make it a number to 10 decimals, and that's the answer. Again, we can click on it, right click with the mouse button, format cells, scientific, make it a number, make it 10 decimals. That's the answer. And then we wanted to also work out the value for delta max, theta b, and delta 0. So in the test, we had these special formulas, and these are obviously a special case where we know what the formulas are. And I'll show you a bit later in the video how to work this out if you don't know what the formulas are. So for the special case, I can just enter in the values for delta max. So let's do that. So I will then have a formula for delta max. If it's not wide enough, just double click on the line in between cells. It'll make it wide. So delta max is equal to 0.005416 times, open brackets for the stuff in the numerator, so multiplied by Q, multiplied by L to the 4th power. So I then multiply by L to the 4th power. If you're getting confused and you don't understand how things work, you can just use another bracket and then put L to the 4th power, close it, and then divide it by F. So you can always use any amount of open and close brackets if you don't understand the syntax of how the program will calculate it. So that's the delta max, and then we want to work out the value for theta b. In this case, the value for theta b is QL cubed over 48F. So this would be equal to, open brackets for the numerator, Q times, open brackets, L cubed, close the bracket, divide by 48 times F, close the bracket, answer. Something went wrong, let's try it again. Theta is equal to, open bracket, Q times, open bracket, L cubed, close, divide, open, 48 times F, close, enter. There's our answer. Alright, so the units, we have to be consistent. Remember, F is equal to EI, and E is Newton over meter squared, I is meter to the 4th power, so the units over here would be Newton meter squared, moments would be Newton meter, theta radian, L meter, Q Newton per meter, delta max meter, theta B in radian. We can always convert to other units. So if I wanted it in kilonewtons, 1 kilonewton is 1 times 10 to the 3. So I could always work it out, whatever the value is, and then I could convert it. So for example, if I wanted it in millimeters, I would say equals to 1 E3 times the value, and that would be the value in millimeters. Just make it a number, right click, format cells, number, let's go to 5 decimals. Okay, and that's the delta max value. Okay, and then obviously the final one that we're looking at is delta 0. And the formula for delta 0 is 0.00244 QL to the 4th power over F. So we can just say equals to 0.002441 times, open bracket for the things in the numerator. So the first thing would be Q times L to the 4th, open bracket, L up power 4, close, close, and then divide by F. Enter. That's the answer. Okay, so I'm always saving because you never know when your computer will go down or something will go wrong. So always save your work so often if you're using an Excel spreadsheet. And that's basically the video in 10 minutes of how you would work everything out by substituting the formulas. Now, let's suppose that we don't know these special formulas and we didn't have time to work out derivatives and substitute all the equations and simplify to these formulas, but we only worked out the final answer for the beam deflection. So the equation would be EI is equal to minus a half MA x squared minus 1 over 24 plus 1/6 open bracket a half QL plus MA over L x cubed, but C1 is 0, C2 is 0. So we'd only look at this formula over here. So the beam deflection would be V is equal to 1 over EI into all of that stuff. And then we know the other values, and then we would be able to work out the beam deflection for any value of x. So let's see how we would actually do that. So I can write the formula just as a text over here. The formula would be EI times V is equal to, this would be minus a half, minus 1 over 2 times NA times x squared minus 1 over 24 times Q times x to the 4th power plus 1 over 6 times, open bracket, this would be a half times Q times L plus MA over L, close the bracket, times x cubed. So that's the formula for the beam. I can rearrange the formula as V is equal to 1 over F times, and then open bracket, it would be minus 1 over 2 times NA times x squared minus 1 over 24 times Q times x to the 4th power plus 1 over 6 times open 1 over 2 times Q times L plus NA over L close times x cubed, and then close again because of that. So that is the formula for the beam deflection. So let's see how we would work that out. We obviously need the value for F, we need the value for MA, we need the value for Q, we need the value for L, we need the value for X. So these are the inputs. So the inputs into the formula that we need to look at, constant inputs, the constants, F, which we know. So F is equal to, and that's what it is. So F is a constant that we are looking for. MA is that value, which we know, Q is obviously what we worked out, so that is Q. So we've got F, we've got MA, we've got Q, and I guess we need L. And we already worked it out, so that's equal to what we worked out. So these are the constants, and then this is the variable. The variable is X. So X is a variable. Let's just say it is 0.5 for the sake of argument. It will be between 0 and L. L is 0.8368, so let's just make it 0.5. And then the function is what we want to work out, and that would be V. So we would then have to put in a formula for V. So let's put in the formula. So this would be equal to, open brackets, 1 over F, and now we have to use constants for the values in the cells so we don't confuse ourselves. So this is in cell C23. So 1 over $C$23, close the bracket, times, open, put some stuff in there, close the bracket so I don't get confused. So this is what I'm going to put in so I don't get confused. So I want minus a half MA x squared. So that would be minus MA, which is $C24, $C24, that's MA, times X value, which is this, squared divided by 2. So that would be minus a half MA x squared. And then we want minus 1 over 24 times Q times X to the 4th power. So that would be minus the Q value, which is C25, $C$25, times X to the 4th power divided by 24. And then I want plus 1/6 into some brackets times x cubed. So that would be plus, let's do it like this, open brackets, put some stuff in there, multiply it by x cubed divided by 6. And now for the stuff inside the brackets, that would be a half QL, so it would be Q times L over 2. Q would be C25, $C$25, times L, which would be C26, $C$26, that is QL, divided by 2, and then plus MA over L, which would be $24, $C$24, divided by L, which is C26, $C$26. Put it in there, and that's your answer. So for any value of x, I can make it 0. The answer is 0. I can make it 0.8368694899. It should be 0. That's basically the value for 0. And it is 0.1, it'll be another value. If it's 0.2, another value. 0.3, another value. So that's how it would work. So I can always copy and paste the formula. And then by copying and pasting, I can plot the entire graph. So that's how we'll do it. Do we have time to do the entire graph? I think there may be enough time. Let's see if we can plot the entire graph. And then you can, if you plot the graph, you can just use the numerical data to work out the values delta max, t to b, delta 0. So I guess this is going to take a few more time. We took 20 minutes, but let's take another 10 or 20 minutes to finish the entire thing. So this is how you would work out functions in Microsoft Excel. So now let's implement the entire thing. So what we do is we want to plot from the minimum of x to the maximum of x. X is going to vary from 0 to L. So let's plot the data for 100 points. So I'm going to have an index I. Let's just call it 1. And then I'll say equals to the value over there plus 1. That would be 2. I then click on it. I right click on it. I say copy. Now I'm going to copy the formula. So let's take 100 points or 200 points. Maybe let's take 200 points. So let's go up to 232. 200. Yeah, let's make it. Let's go to 250 if we can. Shift click, right click, paste. I'm having indices, so I have a certain amount of points. Let's use 250 points. So these are the points, x1, x2, and these points will correspond to, point 1 will correspond to the bottom minimum of x, and point 250 will correspond to the maximum. And if I use these indices, the x value would be equal to an x minimum plus I minus 1 times the delta x. So that is the formula I'm going to use to increment it. So what I can do is I can say x minimum is going to be a certain value, and that would be 0. And then I would say the x max is going to be the value for L, and then I would say my delta x would be equal to the x maximum minus the x minimum divided by the number of points, which is 250 minus 1, close the bracket, and that would be the value that I'm going to increment by. Okay, so this is the I, this is x for particular I. So this is going to equal to the minimum, which in this case is the constant in cell C30. So this would be $C$30 plus open bracket the I, which is on the other side, minus 1 times the delta x, which would be G30, $G30, enter. Click on it, right click on it, copy it, increment all the way to the maximum values, shift enter and paste. And that is all the x's from 0 all the way to whatever the value of L was, 0.8368695. Okay, now I want to work out the V at a particular I. So now we want to implement this formula and then put it in there. So I think you will watch the video in your own time, so I'll just do this in one shot. So this would be equals to, I'm basically copying and pasting what I put in over there. So that would be equal to, open bracket, 1 over F, which is C23, close the bracket, times, open, put some stuff in there, close it, and now I'm going to obviously edit the formula in my own time. So I want to put minus a half max squared. So I'm just going to say minus, open bracket, 1 over 2 times MA, which is C24 times X, in this case it is the value there, squared, minus 1 over 24 times QX FOP, so minus 1 over 24 times Q, which is C25 times X to the 4th power, X to the 4th power plus 1/6 into various stuff times X cubed plus 1 over 6 times some stuff times X cubed. Now, in those brackets, I want to put in the information. I want to put a half QL, so it is 1 over 2 times Q, which is C25. That's Q times L. L is C26. C26 plus MA over L plus MA, which is C24 over L, which is C26. I then go right to the end and I click enter. That'll give me an answer. In this case it's 0. Why? Because the value at x is equal to 0 has a 0 deflection. Then I click on it, I right click on it, I say copy, shift, left mouse, right click mouse, paste. Okay, and then this is in units of meters, and this is also in units of meters. So just save again. I now have a graph of all the information. And let's see if I can plot the graph, what will happen. So I click on the mouse, then I go to Insert, and then I click on Charts, and then I click on Scatter. That's my graph. So let's just take the graph, go upwards as much as we can. Go on the side. Cut. Let's go up and paste. That is my graph of how the deflection will look like. Okay, so we just want to neaten this up. I can click on the graph and then I can right click, I can select, change the chart type, and then I can put a scatter graph with some smooth lines. That's one. Or I can change it to a different type, just a smooth line. So it's not the points, it's just a line going through the points. I then can click on chart design, and then I can add some elements, data labels, grid lines, legends, these type of things. So let's just put some axes and some labels in there. Okay, and then we can obviously format everything over there. So we can change how the graph looks like. Okay, so let's just use this one. This is looking good. So on the axis, I'm going to say distance along beam x in units of meters. Okay, that's the one. And then for the other axis, I can just say beam deflection V in units of meters. There we go. Chart title, graph of beam deflection. Okay, let's change it to something a bit more pretty. That looks nice. Okay, so this is the beam, and then obviously this is in units of meters, and this is in units of meters. So if we wanted to, we could obviously change the values to plot it in meters and millimeters for the sake of argument. But let's just not make things too complicated. So the question that we had was looking for the length, which we worked out, the UDL, the load intensity Q, which we worked out, the delta max, the theta B, and the delta zero. Now we assumed we had these nice formulas to make life easy, but maybe we don't have these formulas. So how would we work out the maximum deflection? So we've got the graph, we can plot the results, and we can work out the maximum deflection. So in this case, the maximum deflection would be the minimum value, and then we multiply it by -1 to get the magnitude of it. So we could plot the graph of everything over there, and then we could say delta min, and then we would say equals to min. That would work out the minimum value. We've got 250 value points over there, so we just scroll all the way to the 250 points, then we select it, put the right bracket, press enter, and then we would say that's the value, and then we would say the delta min is equal to ABS, absolute value of that, and then that would give us a value in meters, and if we wanted it in millimeters, 1e 3 times the value, and that would be so many millimeters. So we could use Excel to plot the entire graph and then work out the value of a particular item, and then if we wanted an angle at theta b, we would then be able to work out the gradient of the curve, and we would work out the gradient using a finite difference, so change in y over change in x, and then we get an answer over there. So we could actually plot the entire curve, work out the derivatives, and if we really wanted to, we could also numerically integrate it to get the answer at the end of the day. So this is how you would use Excel in a practical case within industry, if you're working in a factory or a mine or something like that. So typically, in most cases, you do all of the hand calculations. You work out the values and derivatives and substitute into the formulas with a pocket calculator. But in practical terms, you would actually use an Excel spreadsheet to work out everything and then plot the graphs and curves and things like that. So this is something you can investigate in your own time, and I would advise that you seriously consider how to use Microsoft Excel spreadsheets to do the calculations, because it will make your life very simple and very easy, and it will also help you with your laboratory practicals at the end of the day. Okay, students, I think we'll leave the presentation over here and then you can investigate in your own time. Good luck and all the best. Bye.